Good morning, students. Today we'll be starting with the question answers and numericals of chapter 7 science 1. The first question is a match the column. Difference is there are three columns. Farsightedness, column 2, far away object can be seen clearly, and convex lens in the third column. Presbyopia, problem of old age, bifocal lens. Nearsightedness, nearby objects can be seen clearly, and the third column is concave lens. So you can write the answer in that manner. Question number 2. Draw a figure explaining various terms related to a lens. This is a long answer and the answer is on page number 80. On page number 80, the diagram that you need to draw is given over here, that is 7.3, cross section of convex and concave lens, and then all the things related to that you need to explain, that is center of curvature, radius of curvature, principal axis, optical center, principal focus and focal length. Now this is on page number 81. Now this answer, for this you don't have to write everything that is given in that point. You just have to write down the definition. For example, center of curvature, the center of sphere whose parts form surface of the lens are called as center of curvature of the lens. Just the definition. Question number 3. At which position will you keep an object in front of a convex lens so as to get a real image of the same size as the object? Draw a diagram. This answer is given on page number 83. And this is, the diagram is not drawn over here. This is actually what is it asked. If you see the chart, it is the third one. When it is kept at 2f1, you get the image as 2f2. It is of the same size, real and inverted. For the diagram, you can refer to the previous lecture that I had shared. There I have shared all the diagrams and how to draw it. Then question number 4, that is give reasons. I have shared the answers with you in the next slide. These are the give reasons. This is the first give reason. A simple microscope is used for watch repairer. The second give reason, one can sense colors only in bright light. When you are writing the give reasons, it's better that you write with points. Instead of writing as a paragraph, give points and write the answer. And the third give reason, we cannot clearly see an object kept at a distance less than 25 cm from the eye. Question number 5. Explain the working of an astronomical telescope using refraction of light. The answer is given on page number 90-91. Page number 90, last paragraph, telescope paragraph, till page number 91, the end of the first paragraph, along with the diagram 7.18. Distinguish between, I have shared in the next slide, the answers are given. What is the function of iris and the muscles connected to the lens in the human eye? That is the seventh question. Seventh question answer is given to you on page number 86, last paragraph. All the points are given over there and you can read and see the answers over there. Difference between farsightedness and nearsightedness. Always for a 2 marks question, you need to write minimum 4 points. If it's a 3 mark question, then you need to write 6 points of difference. Here they have given you the diagram. If you draw, it will be nice, but it is not necessary that you need to draw. Similarly, difference between concave lens and convex lens. Again, any 4 points you can learn. 4 numericals are given here. In the next slide, I have shared the formula that we have learned. Even in the previous lecture also, I have shared the formulas with you. You need to learn the formula. And in science 1 especially, the sums are very similar to what is given in the textbook. So you need to understand the textbook sums very clearly. These are the formula that we have learned in this lesson. Formulae is the plural of formula. The first one is called the lens formula, second one is the magnification of lens, third one is power of lens and power of combination of two lens. What you have to remember over here is that P is equal to 1 upon F in meter. Always remember that. If it is given in centimeters, you need to change that. Doctor has prescribed a lens having power plus 1.5 diopter. What will be the focal length of the lens? What is the type of the lens and what must be the defect? So what we need to remember over here is it is plus 1.5. So P is given as plus 1.5. The formula we know is equal to P is equal to 1 upon F in meters. So we can write it as F is equal to 1 upon P, which is equal to 1 upon 1.5. When we solve it, taking the decimal point up, that means it becomes 10 upon 15, and you cancel it and divide, you get the answer as plus 0.67 meter. Now look at the sign, it is plus. That means the moment the focal length is positive, we know that it is a convex lens. And a convex lens is utilized or used to cure hypermetropia or farsightedness. So all the three answers has to be written in this manner. Next sum. 5 centimeter high object is placed at a distance of 25 centimeter from a converging lens of focal length 10 centimeter. Determine the position, size and type of the image. Now first we have to see what is given to us. Converging lens means convex lens. Now let us write down the given part of the data. Height of the object is equal to 5 centimeter. Now we know that height is always on the upward side, perpendicular. So it is positive. Object distance U is equal to 25 centimeter. Now we have also learned that anything to the negative of the optical center is considered as negative and U is always negative. So that is minus 25 centimeter. Since the lens is a converging lens, that is it is a convex lens, the focal length of the lens will be positive 10 centimeter. So we have understood what is the given part. Now what we need to find out? We have to find out the position, that means we need to find out V. We need to find out the size, that is the height, and the type of image, means whether it's real or virtual. So applying the formula 1 upon V is equal to 1 upon U minus 1 upon U is equal to 1 upon F. Changing sides, what do we get? We get 1 upon V is equal to 1 upon 10 plus 1 upon minus 25. Solving it as LCM, we get 3 upon 50. It's continued in the next slide also. Therefore, V is equal to 50 upon 3 equals to 16.7 centimeter. So, V is the distance. So, distance is 16.7 centimeter. Now, we have already learned the formula, that is magnification 1, V upon is equal to H1 upon H2, or that is height of the image upon height of the object. So, height of the image becomes, by cross multiplying and changing places, we get minus 3.3 centimeter. Now, the moment it is minus, that means it is going in the downward direction. So, whatever the question is asked, the size of the image is 3.3 centimeter. So, the negative sign shows that the image is real and inverted and the image formed is diminished. This is how we need to write the answers. This is a easy sum. Three lenses having power 2, 2.5 and 1.7 diopters are kept in touching in a row. What is the total power of the lens combination? So P1 is 2 diopter, P2 is 2.5 diopter and P3 is 1.7 diopter. So total P will be P1 plus P2 plus P3, which is equal to 6.2 diopters. An object is kept 60 centimeter from a lens, gives a virtual image 20 centimeter in front of the lens. What is the focal length of the lens? Is it a converging lens or a diverging lens? Again, we need to write down what is the given part. Object kept 60 centimeter. That means object distance U is equal to minus 60. As we know, U is always 60. Gives a virtual image. Now the moment it's a virtual image, that means it is in front of the lens. Hence V is also 20 centimeter. Now by applying the formula, we get F is equal to minus 30 centimeter. Now if it is minus 30 centimeter, that means focal length is negative. Who gets a negative focal length? We know a concave lens has a negative focal length. Hence this is a concave lens. So the focal length is negative minus 30 centimeter. Thank you. That completes the question answers. Next week we'll be starting with the next chapter.